Okay, hi everyone, it's time we start. So welcome everyone to the last lesson of the pre-contest preparation. So today we are going to look at lesson 5, magic squares. I am teacher Kevin from Think Academy. Nice to see you all. So let's cut to the chase and start with a simple magic square here. We have a 3 times 3 magic square. And first of all, the first point, key point, is there are two special numbers we need to know about magic squares. The first is, and oh, right, if you have any question, because we're running low, we're running a tight schedule today. So if you have any question, you can note it down and save until the end of the lesson, and I'll answer them all together, okay? Right, so let's have a look at this magic square right here. So first, the first number is the magic sum. What is a magic sum? A magic sum is the sum of each row, each column, and also the two diagonals. So let's say for each row, the magic sum is, so for each row, the magic sum is 20, 20, 20. Okay, this is called the 20. The sum of the three numbers in the first row is called the magic sum. Okay. And then the second thing, the second important number you should know is the number of all the numbers, the sum of all 9 numbers inside this magic square, which is 20 plus 20 plus 20. Because we know these 3 numbers add up to 20, these 3 numbers add up to 20, and these 3 numbers add up to 20 as well. So the sum of all 9 numbers will be 20 plus 20 plus 20, which is 60. And that gives us a really important relationship between the magic sum and the sum of all numbers. I'll write it here, magic sum and the sum of all numbers. All 9 numbers to be specific. Okay, so you see the sum of all 9 numbers is 60. And because we know that each magic sum is 20, so the magic sum times 3 equals to the sum of all 9 numbers. Okay, and in reverse, the magic sum, so in the other way around, equals to the sum of all 9 numbers. And I'm sure most of you have already got the answer, divided by 3. That is correct. I'll write it in red. So this is multiply 3, and this is divided by 3. So knowing this relationship will enable us to calculate some magic square questions. So we can have a look. This is just a summary of the key points I just went through. So the sum of the numbers in each row, column, and diagonal is called the magic number. And the sum of all 9 numbers in the magic square divided by 3 is the magic number. And it can also be the sum of all the numbers in the magic square equals to the magic number times 3. Okay, so we can have a look at an example. So in the magic square, the sum of the numbers in each row, column, and diagonal is the same. The numerals, the numbers 1 to 9 are used in this magic square without repetition because we have 9 squares, 9 cells in total. Complete the magic square. So we don't know the magic sum yet, but we do know the relationship between the sum of all 9 numbers and the magic sum, which is a 3 times relationship. And we can find the sum of all 9 numbers, which is 1 plus 2 plus 3 all the way to 9. And I know you have learned about arithmetic progression and how we find the sum of AP in the previous lesson. So I will just do it. I will just give you the sum directly. You can, if you are interested, you can calculate this on your own. So 1 plus 2 plus 3 plus ... plus 9. This should be equal to first term plus last term, multiply a number of terms divided by 2, which is 10 times 9 divided by 2, so it's 45. So this is the sum of all 9 numbers. And we know the sum of all 9 numbers divided by 3, so 45 divided by 3 will give us 15, which is the magic sum. So for this diagonal here, we have 2 numbers already. That means we can find the number in this cell We know the magic sum should be 15. So we have 6 plus 5, 11 already. Then in this box, we should have 4. And for column 3, we have 2 and 4, which is 6. So 15 minus 6 will give us this cell, which is 9. And then for row 2, we have 5 and 9, which is 14. And then to get 15, we add 1. So in this cell, we should have 1. And then we can find all the rest. So this is for row number 1, we have 2 plus 6, which is 8. And 15 minus 8 gives us 7 in this cell. And then vertically, for the second column, we have 7 plus 5, which is 12. And 15 minus 12 is 3. And then we have used all the other numbers between 1 to 9. So the one left must be the one in this cell, which is 8. And to check if you're correct, we have 1 plus 6 plus 8, which is 15. And 8 plus 3 plus 4, which is 15 as well. So we are correct. So that's how we complete this magic square. Okay, good. Then we can have a look at this one right here. So complete this magic square containing numbers 2 to 10. And all the rows, columns, and diagonals must add up to the same number. So for this one, we don't know the magic sum as well. And we only have 2 numbers. Okay. So you find that it is hard to find out the we can find the magic sum, which is 2 plus 3 plus ... all the way to 10, and that will give us so first term plus last term times the number of terms 9 and divide by 2, which will give us 6 times 9, 54. So the sum of 2 to 10, the sum of all 9 numbers is 54. And then we can have 54 divided by 3, which is 18. And that will give us the magic sum. But you find that we can only find the number that should fit into this cell, which is 5. So 3 plus 5 plus 10 is 18. And we can't go any further, which leads us to the second key point today. Okay. The second key point is all about the center cell. Okay, the number in the center of this magic square. Okay, all the things we're going to talk about in the rest of the lesson is going to be about this center. Okay, it's really important and really useful. The center number. Okay, so the first thing we can have a look. The first thing is there is a relationship between the number in the center and the magic sum. What is the relationship? I won't tell you right away, but let's have a look. So say we have the magic sum of the first row, the second row, and the third row. So altogether, we have 3 magic sum now. All right. And then on the magic square on the right, I will have different arrangements. So I will have 1 row, 1 column, and then 2 diagonals. Okay, so altogether 1, 2, 3, 4, 4 arrows. That means we have 4 magic sums. Okay, so you see the difference between these 2 magic squares, difference between the way we're counting, okay, is 1 magic square. Keep this in mind. This is really important. So the difference is 1 magic sum. Sorry, not 1 magic square, but 1 magic sum. Okay. And then let's have a look. So for the first magic square, the 3 magic sum, they represent, let me change the color. So they represent the sum of 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 numbers. Okay. And for the second one, for the magic square on the right-hand side, we have so 1, 2, 3. That is for this diagonal here. And then for the second diagonal, 1, 2, 3. And then for the row, for the horizontal one, 1, 2, 3. And then for the vertical column, we have 1, 2, 3. So what do you find? You found that the sum, all the 3 magic sums in the first magic square, they are counting all the 9 numbers inside once. And then for the sum of the 4 magic squares, the sum of the 4 magic sums on the right-hand side, for this magic square, the sum of the 4 magic sums is all the 9 numbers counted once with the middle number, the number in the center, counted 3 times extra. Okay? So if we take the 3 extra times out, And that will be the difference between this magic square and this magic square. And remember, we said the difference is one magic sum. So one magic sum will be equal to, I'll write it in red, 3 times center, because we're counting the center 3 more times, and we have one more magic sum. So they must be equal to each other. Okay, so this is the second key point for magic square today. One magic sum equals to 3 center. Okay, and with that being said, we can solve lots of other magic square questions. But before we get going, I want to tell you the last key point we have today. That is, so I will have do I have another one? No, I don't have another one. So I'll just use this diagram to write. So say this is the center, and I have a number here, 5, and the 10, and I tell you that the magic sum for this one is 20. Then we will have, obviously, the center number will be 5. Yeah, but you see, one number plus 2 number, the 2 other numbers on the diagonal plus the one in the center will give us the magic sum. Okay, so we can represent it. So just try to be happy with it, but you don't have to be happy with it. So we can represent the 3 numbers in the diagonal with 3 letters. We have A, B, and C. Okay, and they add up to one magic sum. Okay, so we can write it here, the relationship A plus B plus C is one magic sum. And then we can use this relationship we got here. So we know one magic sum is 3 times the center number, and we know the center number is B. So one magic sum, we can express it as the equivalent 3B. So that means A plus B plus C equals to 3B. That means the 3 number adding up will equal to 3 times the center number. Okay, so we can minus a B on both sides of the equation, and the equation still stands. A plus C. That means the 2 other numbers, they add up to 3B minus B, which is 2B. So A plus C is 2B. This is the second key point. The third key point we need to know. And that's all. That's all the key points we need to know for today. And then we can solve all the rest of the questions with these 3 key points. Okay. So just to add up to the third key point. So we can have this diagonal, the 2 numbers added up will be 2 times the center. These 2 numbers on the diagonal added up will be 2 times the center. These 2 numbers in the middle column, their sum will be 2 times the center. And these 2 numbers, the 2 numbers in the middle row, they added up to 2 times the center number. Okay. Then some students used to ask me this question, say, teacher, say if I have 6 here and I have 8 here on this so I have two numbers in these 2 boxes. Can I get 6 plus 8 divided by 2 and I get 7 here in the middle for the first row? That is a big wrong. Okay, for the third key point, the only specification, the only restriction we have is we're always working around the center. Okay, not this one, not this one, not this one, not this one, the center. We're only working with the center. All right. Okay, so keep that in mind. We can look at all the rest example questions for today. All right, so yeah, before we look at the other example questions, I have prepared a really simple video just to show you the second key point in a more straightforward way. So we can have a look. This is the sum of the 3 magic sum, the 3 rows. And then we have 4 magic sum. And you see we have counted 3 more center number. And that will be the 4th magic sum. Okay, good. So we can have a look at all the rest of the example questions. What is the value of x in this magic square below? So remember the third key point. This number plus this number equals to 2x. So 22 plus 26 equals to 48. And 48 divided by 2, I shouldn't write it like this. I should write complete steps. 48 divided by 2 is 24. So x is 24. Okay, I'll switch back to blue. And then in the magic square, the sum of the numbers in each row, column, and diagonal is the same. What is the value of a right here? Okay. So we cannot find the magic sum directly, and we also cannot find the sum of all 9 numbers, but we can make use of the third key point, which is the center number equals to this number, add this number, and then divide by 2. Okay, so 12 plus 8, you find that 12 plus 8 is 20, and 7 plus 13 is also 20. So 20 divided by 2 will give us the center number, which is 10. We have 10 here, and then we can find the magic sum. The magic sum will be 12 plus 10 plus 8, which will be 30. Or we can make use of the first key point, the second key point, which is we have 10 in the middle. The second key point tells us that the sum of all 9 numbers will be the middle times 3. The magic sum. The magic sum will be the center number times 3. So 10 times 3 will give us directly the magic sum, which is the sum of each row, column, and diagonal, 30. So we have 7 plus 12 in the first column. We have 19, and 30 minus 19 will give us the value of a, which is 11. Okay. Yeah, sorry. Just to remind, the second key point should be the center number times 3 gives us the magic sum instead of the sum of all 9 numbers. Okay, correct myself. Right, and then in the magic square, the sum of the numbers in each row, column, and diagonal is the same, completed. So again, we can use the reverse. In the reverse order, the second key point. We have the middle number, and then we can find the magic sum by multiplying the 3 to the middle number, the number in the center. So the 14 times 3 is 42. Then we know that the magic sum will be 42. We have in this column 14 plus 6, which is 20. So 42 minus 20 is 22. So in this cell, we should have 22. And then in the other diagonal, we have 23. So 42 minus 23 is 19. So in this one will be 19 as well. And then we can solve all the rest. So these 66 plus 19 is 25. And then 42 minus 25 is 17. 22 plus 9 is 31. And then 42 minus 31 is 11. Okay. And then 6 plus 9 is 15. 42 minus 15 is 27. So this will be 27. And then 22 plus 19 is 41. So 42 minus 41 will give us 1. So it'll be here. And just to check, so we will look at the middle column just to check if we're correct. So 27 plus 14 is 41. And 41 plus 1 is 42. Okay. Right, and then keep going. Complete the magic square containing the numbers 2 to 10. So this is the one we weren't able to do before, but now we know key points 2 and 3. So we will be able to find it. So we know the sum of all 9 numbers is 2 plus 3 plus ... plus 10, which is 54. That we already know. And then we can find 54 divided by 3. So the sum of all 9 numbers, remember the 3 rows, 3 magic sum added up, gives us the sum of all 9 numbers. So the magic sum will be 18. And then we can find the last row, 18. Last row is 13, and then 18 minus 13, so 5 right here in this cell. And then using key point number 2, the center number times 3 is the magic sum. So 18 divided by 3 will give us the center number, which is 6. And with these two numbers, we can actually solve all the rest. So we will have 5 plus 6, 11, and 18 minus 11 will give us this cell right here, 7. And 3 plus 7 is 10. 18 take away 10 is 8. So here will be 8, sorry. And in the middle row, we have 8 plus 6, which is 14, and 18 minus 14 is 4. And for this column right here, we have 5 plus 4, which is 9, and 18 take away 9 is 9. And finally, for the first row, we have 7 plus 9, which is 16, and 18 take away 16 is 2. So we have used 2, 3, 4, 5, 6, 7, 8, 9, 10. All the numbers. Okay. Right, and the last one. So find the value of C in the magic square below. So with this one, we only need to use the property of magic squares. We actually don't need to make use p points 1, 2, and 3. Okay, just use the property. That's the sum of this row. Sorry, the sum of this column and the sum of this diagonal is the same. They both equal to the magic sum. And we actually don't need to know what is the number in this cell here. We can represent it with the question mark. Okay. So that means 9 plus 4 plus the question mark is the magic sum. 5 plus C plus the question mark is also the magic sum. They're equal to each other. So say if I have 1 plus C equals to 2 plus C. Oh, sorry, that is a bad example. So basically, if we have two same numbers, the question mark represents the same number on both sides of the equation, we can cancel it out. Okay, so that means 9 plus 4 will equal to 5 plus C. And we can find C by minus 5. So subtracting 5 to both sides of the equation. And we will have 9 plus 4 minus 5 equals to 5 plus C minus 5. And then plus 5 minus 5 cancels out. So C will be 9 minus 1, so 8. Okay, so that concludes everything you need to know about magic squares, and that concludes all we need to know in lesson 5 today. Do you have any questions, everyone? Yes? No? No questions? If you have no questions, you're free to leave. If you have questions, you can raise your hand now.
I've seen this thing on math where it's called the magic disappearing square. So there's basically a triangle made out of shapes, but if you rearrange the shapes, one of the squares disappear.
Is that like a game?
No, it's something in math.
Ah, okay. So it's a special type of magic square, yeah?
No, it's like a shape made out of shapes. So it's just a triangle made out of different shapes.
Yeah.
But if you rearrange the shapes making the triangle, one of the squares in the triangle disappear.
Ah, I see.
The triangle is made out of squares, little squares.
Yeah. Yes, I've seen that before. So yeah, that is actually not included in the square, in the magic square. So it's I think it is a geometry problem in another module that we are not discussing today. But yeah, it is a really interesting topic, and I would love to discuss more with you, so apart from the lesson. But just for today, do you have any other question about magic squares? Okay, if you have no other questions, then I wish you enjoy the rest of the evening and good luck with the...
Oh, and also, can you send all of the ways to answer the question? Like all of the key points?
Yes, all of the key points. No problem.
WeChat.
Yeah, no problem. Yeah, and good luck to everyone for the calculation contest on September 1st. Wish you all the best. And if you have no other problems, you're free to leave. And I'll see you around at Think Academy.
Wait, why is there a kid lost in IKEA?
Bye.
Someone is lost in IKEA.